Hello everyone. Our lessons today is about the symmetry and odd and even functions. Okay, let's start. Lesson 0.3 Symmetry and even or odd function. Okay. Uh, I think as you learned it in at your secondary school, but I want to review you some knowledge about the symmetry, and then we will um, review how to conclude functions in the odd or even or neither. First, we'll together about the symmetry. We have three types of symmetry. It is symmetry y reflect across the y-axis. So we call this is y. Okay, I changed. Y-axis symmetry. The second one is x-axis symmetry. And the last one is origin symmetry. Yeah, I said y-axis origin. It is three factor of the rectangle coordinate system. So we have coordinate system here. Y is y, x-axis and y-axis. Okay. And we have the definitions that a graph is symmetric with respect to y-axis. If whenever the point x, y is on the graph, the point x negative y is also on the graph, and it is y-axis symmetry. The graph reflects across the y-axis. So reflection across the y-axis. Yeah. So we can sketch one graph. It is the model, the formal graph that is very familiar with you, with the y-axis symmetry is parabola. Here. The graph is symmetric with y-axis when if whenever point x, y on the graph. The point negative x, y also on the graph too. It is the y-axis symmetry. X, y on the graph. Negative x, y is also on the graph too. And it is the same manner with the x-axis symmetry, that is reflection across the x-axis. Across the x-axis. So we can sketch graph here, and the point xy, if the point xy is on the graph, and the point x negative y is also on the graph too. So we have x, y lies on the graph, and the point x negative y it also lies on the graph too. It is a reflection across the x-axis, or we also call x-axis symmetry. Or another way we can use the term a graph is symmetry. We use an adjective. With respect to the x-axis. Yeah, this is a three ways to call the x-axis symmetry. X-axis symmetry reflection across the x-axis of graph is symmetric with represent to the x-axis. It is the same manner or the same way to say to conclude the y-axis at origin. And when the graph is origin symmetry, it is reflection through the origin 0, 0. And when we take point xy lies on the graph, the point negative x negative y it also lies on the graph too. So with the origin symmetry, we have x y lies on the graph, and the point x negative y also lies on the graph. Yeah, it is a definition of symmetry. So how we can test for symmetry? I want to say that about the symmetry in at high school, you also have questions that find out or define the symmetry of the equation. and maybe it appear in the multiple choice question MCQ. So it requires you to define the form of symmetry as fast as possible. So we often use the informal test for symmetry. But I want you to cultivate the knowledge. So I will introduce two methods to test for symmetry in formal and informal. So when you do the questions require you over responding, you must use the formal test for symmetry. And when you have questions, multiple choice questions, you will use the informal test for symmetry. Maybe it can help you solve the problem faster. So we learned the two methods to test for symmetry, and we do some exercises together, and I think you can feel easier when you do your homework or you take an exam in your school. Okay. The formal test, maybe I will clear it. We have the two methods. The first one we call that informal test. And the second one is informal test. For symmetry. Okay. About the formal test. Formal test. We are replacing with y-axis symmetry. We replacing x with negative x, and it yields or produces an equivalent equation. Replacing. I use replacing x with negative x. Yeah, x with negative x. And in x-axis symmetry, we replacing y with negative y. Here, y with negative y. And the last one, we replacing both variable x with negative x and y with negative y. Because now you see the point x, y lies on the graph is also mean that the point negative x negative y also lies on the graph. So x negative x, y negative y. So we must replacing x with negative x, y with negative y in the origin symmetry, and all of them must produce. We use the verb produce or yield an equivalence equation. Yeah, and in the formal test, we work with the variable x and y, replacing x with negative x in y-axis symmetry, replacing y with negative y in x-axis symmetry, or replacing x with negative x, y with negative y in the origin symmetry, and our working produces or use an equivalent equation. And in the informal test, you replacing or you substitute one number. One number is depends on you. You can choose one or two or three, and you in the first one and the second one you will substitute with the another in the opposite side of the number, and then if we have the same variable y or answer. So I can informal test substitute substituting a number and is opposite for x, and it is given the sequence y value. And in x we substitute a number and it's positive for y, and it given the same x value. And the last one, we substituting a number and its opposite x and given the opposite y, x, and then it is opposite y. Yeah, it is a theorem about the informal test. Maybe you can feel easier when we do the exercise together. So formal test, we working with we work with the variable x, y, and informal test we work with number. Because algebra it use the ladder or the letter with an s to represent the number. Okay, it is so theorem. We have some example about the symmetry. Okay, we have a question. Find the type of symmetry for the graph. A y equals to x squared minus x b to and c absolute of y x negative. Maybe our graph is not symmetric. Okay. If you haven't been not familiar with the sorry, you haven't if you haven't been familiar with the symmetry, you can use the informal test to find the type of symmetry first, and then you write down in your on your paper by using the formal test. So the first one, y equals to a cube minus x. You can choose one number to substitute for x, like 1, be like s equal 1 and y, so y equal to minus 1, it is 1. And x negative 1 and y is 2 negative 1 cube minus negative 1. It is negative 2 plus 1 is negative 1. So we can see that when you replacing x with negative x, we produce y with opposite y here. So it is easy for you to conclude that the graph of this function is the origin symmetry. And when you the questions require you write out something to define the type of the symmetry, you can write like replacing with negative x and y with negative y. So we have y with negative y is a negative y equals 2 x is replacing with negative x minus negative x. So it is negative y equals negative 2x squared plus x. So we change the sign of both sides. So we have y equals 2x squared minus x. And it is the same as the questions here. It is the same as here. So we write it is an equivalent equation. An equivalent equation, so it is the origin symmetry. Yeah, it is the informal test. And here's the formal test. Yes, you can use the informal test if the type of questions is multiple choice, and when it is open responding questions, you can use the formal test here. Question B. Okay. First of all, we do by using the informal test. So you you substitute x with 1. Why I choose the number 1? Because number 1 is very easy to calculate or compute. You can choose another number, but I recommend you that you should use x equal 1 and negative 1. It make our calculation easier. X equal 1, so y equals absolute of 1 minus 2, that is negative 1. And when x equals negative 1, y equals absolute of negative 1 minus 2 is also negative 1. So here, x1 or negative 1, it has the same y value. So it is the y-axis symmetry. Maybe you are often confused that when is y-axis, when y-axis symmetry and when we have x-axis symmetry. So you can sketch a small rectangle coordinate system and let the point let 2 points in the coordinate system and we can easy to conclude like that. We sketch a small coordinate system and let the point, first one is 1, -1 here, x1, y -1 here, the first one, and the second one -1, -1 in here. So 2 points will reflect to the y-axis. So we call this y-axis symmetry. And in the formal test, we write replacing x with -x. We have, because it's y-axis symmetry, you can test by informal test. And you write down here, x with -x, we have y, it's also y because we don't change y. Y equals absolute of x. But we replace it as with -x, so it is absolute of -x minus 2. So y equals x minus 2. It has absolute of x negative 2. It has the same with the fractions, and we can write down an equivalent equation. So the graph is y-axis symmetry. So if you want to write down replacing x with -x or y with -y or both, you must find the type of symmetry first by using the informal test. And you don't write it on your paper, but you write by the variable like x with -x and y with -y. Yeah, it is question A and B. In question C, we see that A and B, we have a y equal, so we work with x variable. But in the question C, we see that we have absolute y and x is maybe is so independent. So we work with y variable, do not work with x variable. Okay, I will. See, absolute of y equal x minus 2. Informal test, because it is absolute of y, so we replacing y. Y equals 1, so absolute 1 equals x minus 2 and x equals 3. Y equals -1, so absolute of -1 equals x minus 2, so x equals 3 2. It is the two opposite y and x have the same value, so This is the axis symmetry. And in the same way, you can sketch a small rectangle coordinate system here and point and plot 2 points to the coordinate system to find out x or y axis symmetry. The first point is 3, 1, 3, 1 here, 3, 1. Maybe you can you cannot let this point with right coordinate, but you must but you will let with the correct quadrant. It is positive and positive, so it lies on the quadrant, first quadrant. And the second one is 3, -1 here, the second quadrant. Sorry. The fourth quadrant. Yeah. -1, 1, and 3 here. So these 2 points is reflect to the x-axis. So we point this type of symmetry of the graph is axis symmetry. It is informal test, and when you use the formal test, you would write replacing y with -y. We have it is y, and we're replacing with -y, so it is -y equal x don't change -2. Absolute of -y is absolute of y equal x minus 2. And it is the same as the fractions, so we have an equivalent equation. And our questions done. Okay, this is the first part of our lessons today about the symmetry. We have 2 types of symmetry: the y-axis symmetry, the x-axis symmetry, and the origin symmetry. Also, it is a special graph, and almost our graphs we have is not symmetry. And if you replacing x, y, or both of them, and we don't have the same x, the same value or opposite value of 2 variables, we can conclude that they are not symmetry. And we will do some exercise in the next part that we conclude the graph is not symmetric, or it no symmetry. Okay, now we move to the second part of our lesson today about the even odd functions, or maybe it is neither even nor odd function. Okay, I clear my board to have more spaces for the next part. even, odd, or neither function. We have a definition. A function is defined to be even if f opposite x equal fx for all x in the domain of fx. We have two conditions here. The first one, I think that almost all students remember it. It is f negative x equal fx. It's very easy to remember. But the second condition for all x in the domain of fx. A lot of students forgot this condition. So when we do the exercises, you must find out the domain of fx first, and then we do, and then we replacing x with fx here, x with negative x here, and if the first condition is satisfied and the second condition satisfied, we conclude that it is an even function. So we see here in the definition of even function, we have 2 points, x at x with y equal fx. So we have a point x, y, and when negative x, we have y equals f negative x. F negative x equal fx. So we have the point negative x, y. So graph have 2 points x, y, and negative x and y, and the variable. So you can substitute all real number for x and y in the domain of fx, or x in the domain of x. So the point x, y lies on the graph, and the point negative x, y is also lies on the graph. So it is the y-axis symmetry. So we have a conclusion that even function have graph with y-axis symmetry. And we have some example of even functions, like with the exponent is even number. When you substitute, when you're replacing x with negative x, it has the same value. So with the functions has all term are has on term having the even exponent. It is the even function, like x equal y equal x squared. It is parabola. Y equals x4. Y equal x6 minus x4 plus 3. All of the exponents of the term is even number. It is they are even functions. Okay, this is the first type of functions, even functions. And we move to another type. A function is defined to be odd if f negative x equals negative fx. And it also requires the condition all for all x in the domain of fx. And in the odd function, we have the point x, y equal fx. So we have a point x, y. And when we replacing x with negative x, y equals negative f of negative x. So it is negative fx. So it is negative y. So we have the point negative x, negative point, and negative y. And as we learned in the first part, so we can conclude that odd function have a graph with origin symmetry. And when you replacing x with negative x, you have at x not equal is not equal nor equals or not equal with negative fx. You can conclude the graph is not even, is neither even nor odd functions. Okay, this is the theorem. And we do some exercises to illustrate this theorem. Okay, I can get my watch. determine whether the following function are even, odd, or neither. A at x equals x cubed minus x. B gx equals x squared minus 4. C hx equals x squared plus 2x plus 2. Okay, we do it together. The first step, you must write down the domain of fs, gs, and hx. Domain D equals. It is all of them are polynomial functions. So when you learn at your secondary school, you know that when the function is polynomial, the domain of function is all real number. So we write out that x equals L. D equal error. The domain is all real number. All real numbers is either on x-axis. So when x lies, when the point have x coordinates lies on the graph, the point with the coordinate negative x also lies on the graph. So if the first condition of even or odd function is satisfied, and if you have the domain like D equals L, eliminate number 2 like this. You can see that we have an x-axis here. This is the origin, and number 2 we don't have the number x equal 2 in the x-axis. So the negative 2 is also not it not have the opposite number. So if not, we can conclude that it is not even or odd, or can even on odd functions. That's the first step, is not satisfied. And if D equal error, is a whole real number, you will do the second step to conclude what type of these functions are even or neither. So if we have the domain D equals error eliminates 2, we can conclude right now neither. And we don't want to do the second step. But here all of them are polynomial function, so D equal error, and we must check the second condition. Question A. we write that fx equals a cube minus x. F negative x. F negative x, it means that you're replacing it with negative x in the function. It is negative x cubed minus negative x. So it is negative cubed. It is negative. Negative with the power, with the exponent is odd number. You must remain the negative sign. Is quick. Negative minus negative x, it is plus x. So when you factor these expressions by negative, it is x cubed minus x. Fx is x cubed minus x, and it is negative of x cubed minus x. So it is negative fx. So when you replacing negative x, you have a negative fx. So you conclude that it is even function. It is odd function. Sorry. Decide to divide the type of functions very easy. That if all term of the x in the functions have the odd exponent, it is odd function, and if have the even exponent, it is even function. And if it is a mix of odd and even exponent, yes, it neither even nor odd function. Okay, odd function. We move to question B. Gx equals x squared minus 4. You will replace x with negative x. We have a negative x squared minus 4. And it is x squared minus 4. X squared minus 4, squared minus 4. It is the same as gx. So we conclude that it is even function. Of course, you must write down that d equal error before you do the second step. And question C. P equals all the number. Okay. Hx equals x squared plus 2x plus 2. So we're replacing x with negative x. We have x negative x equals negative x squared plus 2 negative x plus 2. It is x squared, negative squared is we remove the negative sign. 2 times negative x is negative 2x plus 2. The first term same, the last term same, but the second term is not the same. So it is not equal x or negative x. You can write this symbol to denote. So we conclude that neither even nor odd function. Yeah. It is our lesson today about the symmetry and even and odd functions. And now I will give you some exercise for you to do at home. And in the next assignment, I will check and solve the exercises I give for you to do at home. Okay. I will write down some exercises for you. I think it's easy now. When you do the exercise at home, you will find out that the symmetry and even or odd function is also easy like another part we learned before. Okay, I clear the board. Question 1, check for I6. Why I6? For origin, symmetry. A, y equals x squared minus 2 B, y equals x cubed plus x. C, y equals x over x squared plus 1. D, y squared equals x minus 2. E, y equals x cubed plus 3. F, y equals x over x squared minus 1. Be careful to write down the exercise on your notebook because it has a small difference about the question A, D, B, E between the question A, D, B, E, and C and F. Okay, this is the first question. Question number 1 I give you to do at home. We have a question 2. Find intercept, symmetry, and sketch the sketch a graph without using a calculator. We have 3 smaller questions here. A, y equals x plus 2. B, y equals 1 over x, the reciprocal function. And C, y equals x squared plus 3. This is a parabola line, hyperbola and parabola. Okay, this is your homework. Do it and I will solve it in the next assignment. Goodbye and see you later.